Dinosaurs have a special place among prehistoric animals. During the Mesozoic era, many species of dinosaurs dominated the Earth. Let us talk about their less known but very interesting ancestors and their fight for a place under the sun. This is how it all started. Life on Earth before dinosaurs. The supercontinent Pangaea has changed the climate, flora, and fauna. The Permian period, or simply the Perm, began 300 million years ago on the planet. It ended the Paleozoic era and lasted 47 million years until the Mesozoic. During that time, two continents, Laurasia and Gondwana, formed a supercontinent Pangaea, with a panthalous mega-ocean washing its shores. As you can imagine, the merger of two continents significantly changed the climate, flora, and fauna of the planet. During the previous Carboniferous period, the Earth was warm and humid. There were many lakes, rivers, and swamps. Forests of giant spore plants like ferns and club mosses covered the land. Trees had 1.5-meter diameter trunks and grew 10 meters tall. Mega mushrooms, prototaxites, could be seen through the haze of swamp vapors. Those green, blue-brown giants sometimes grew higher than a 2-story building. Cartilaginous fish lived in the seas. They looked like real chimeras. The distant ancestor of the shark, the Helicoprion, was perhaps the scariest because of a dental spiral with 2 or 3 turns. Its body reached 10 to 12 meters, and the diameter of the dental spiral reached 90 centimeters. Its terrifying lower jaw was equipped with many sharp teeth. Despite all this, Helicoprion teeth failed to break hard shells and ate only soft food like squid, krill, and shrimp. During that period, land animals were not numerous. However, some of them were big. Even insects were big and looked like monsters from horror movies. Imagine huge dragonflies, Meganeurites gracillipes, flying over a lake. Their wingspan reached more than 30 centimeters. The predecessors of our cute dragonflies were ugly and scary. They had predatory jaws, bulging eyes, and spiked legs. A distant relative of modern centipedes, a terrible arthropleuray, lived in the swamps. 3-meter insects ate tons of vegetation per year. They also liked to eat small amphibians. They tore them apart with strong jaws with sharp teeth. Most likely, all those giant creatures appeared due to an excess of oxygen in the atmosphere. The level of oxygen at that time was 35%. It is almost 14% higher than we have now. There is a hypothesis that the size of insects depends on the high level of oxygen. The insect respiratory system consists of tracheas. Those are tubes that supply oxygen to various organs. Because of those tubes, insects can't grow bigger now. Remember, the bigger the insect, the longer its windpipe. At the current oxygen level in the atmosphere, no oxygen will reach the organs during the inhale. Only if the concentration of O2 were higher, long trachea would deliver oxygen to the body organs. That is why insects reached incredible sizes during the Carboniferous period. If in the future for some reason the oxygen level goes up, let us say up to 40%, the insects again would turn into huge monsters. The scientists calculated that dragonflies would reach the size of a small aircraft and beetles the size of a small tank. The oxygen level also affects the size of animals, but to a lesser degree. Science does not offer an exact explanation why. One of the hypotheses says that higher oxygen levels allow big animals to get more oxygen to the muscles. In addition, higher O2 is good for the development and rapid growth of embryos in eggs. With the onset of the Permian period, the amount of oxygen in the air decreased. That's why large insects and other species lost the size-based advantage and got smaller. This evolutionary change did not happen overnight. but took millions of years. The formation of the supercontinent Pangaea significantly changed the climate. The climate during the Carboniferous period was pretty much the same all over the planet. Now it got colder and had several zones. The southern part of Pangaea, including modern India, Australia, and South America, were under ice. Snowcap covered the pole. Also, there were hot, rainless deserts inside Pangaea. There have never been more deserts on Earth than in those days. The coastlines had moderate temperatures and humidity because of the ocean. In general, the Perm climate was more like ours than Carboniferous or Mesozoic. Climate changes destroyed old flora and fauna. Without swamps and marshes, ferns and horsetails could not grow and proliferate. As the swamps became smaller, the diversity of spore plants shrank, and gymnosperms began to dominate the planet. Those were all kinds of ginkgos, coniferous trees, and palm-like cyads, with thick trunks and leafy crowns. Animals also had to adapt to the new climate and adjust to arid conditions. They had to reinvent themselves to survive on a new supercontinent. Amphibians were at a disadvantage because their moist, porous skin could not stand dry air. They could survive only in lakes and marshes. No wonder many species of amphibians became extinct. On the contrary, reptiles rapidly spread across the globe because they adapted much better than others to the new environment. During the Permian period, reptiles constituted 53% of all tetrapods, compared to 13% in the previous era. At first, reptiles had small size resembling modern lizards. They fed mainly on arthropods and worms. With time, larger species appeared to prey on smaller ones. Most of the predators had powerful jaws with strong teeth, good for hunting. Nothing could prevent the reptilians from completely conquering the planet. However, a real catastrophe broke on Earth. What happened? Let us picture the last days of the Permian period before the disaster. A 4-meter, 200-kilo Dimetrodon lived in a food-rich ocean. The Dimetrodon was one of the most successful predators of the Permian. Its sharp teeth, unlike most reptiles, consisted of incisors and serrated fangs. They were perfect for eating flesh. Consisting of thick skin stretched over vertebral growths, the backsail was a huge advantage. The Dimetrodon used it for mating games, camouflage, and swimming. The sail helped to regulate the body temperature. It also gave a head start in hunting. Without the sail, the body of a reptilian would warm up from 26 to 32 degrees Celsius in 205 minutes. With the sail, it took only 80 minutes. Thus, the Dimetrodon could hunt early in the morning before others woke up and moved. The sail also helped if the enemy, like trematopids, got in the way. Trematopids were predatory amphibians, up to 80 centimeters long. Well adapted to life on land, they used sharp, long upper fangs to attack. However, the trematopids were very slow. Moreover, they could not hunt in early morning because they needed time to warm their cold body. That is why they were easy prey for the larger and more agile Dimetrodons. During the Permian period, everybody was searching for food. A 3-meter Gorgonopsia was a predecessor of mammals. It did not need to warm up in the morning because it was warm-blooded. In addition, it was partially covered with fur. Gorgonopsia also had saber-like fangs and a pineal third eye on the top of its head. It was like a periscope a reptile used for hunting at dawn. It was the best time for hunting. The Gorgonopsia also had a well-developed brain and cerebellum. It had good movement coordination. It also had long, straight hindquarters. The Gorgonopsia was not scared to hunt larger prey. Put all details together and you will get a picture of the most dangerous predator of the Permian period. The Gorgonopsia hunted even for a 4-meter herbivorous Periosaurus peacefully eating the tree bark. With sharp 15-centimeter dagger fangs, the Gorgonopsia could bite through the pineal bone armor of a clumsy animal. Its hunting strategy consisted of a series of attacks and retreats. First, it jumped on the prey, then bit off flesh and retreated. It attacked again and again until an agonized prey was dead. Cynodonts were another distant ancestor of mammals. Resembling otters in appearance, they were up to 60-centimeter reptiles. They were warm-blooded and furry. It meant that they did not depend on temperature fluctuations. Cynodonts could hunt at night when bigger predators were resting. Hunting together, they could aim at bigger animals and rarely left without prey. Their success depended on sharp teeth. Sharp fangs easily tore prey to pieces. Incisors captured and bit off the flesh. Flat molars with many cutting edges chew the prey. The thecodonts, who lived in the depths of Pangaea, had to move and search for a better place. The reptile looked like a modern crocodile with long legs. Together with dinosaurs and birds, it was the first ancestor of the crocodile. Some kinds of thecodonts could move on 2 limbs very, very fast. Imagine that the thecodonts traveled for many miles until they found a green oasis. There, they met herbivorous ethosaurs among the trees. Those slow and clumsy reptiles were also the forerunners of dinosaurs. They had shelled and spiked backs to protect them from predators like the thecodonts. However, they were also amphibious euschaliums. Those were easy prey for lunch. 252 million years ago, a catastrophe boiled inside the Earth. Scientists learned about it when they studied the geological layers of the planet and found ash layers. It supported the hypothesis that the catastrophe was caused by active tectonic shifts inside the planet. After the merger of the continents, the Laurasia and Gondwana lithospheric plates continued to move, and as a result, the southern plate divided under the northern one and formed huge holes on the surface in what is now India and Siberia. Thus, hot gases and magma splashed out from the inside of the planet to the surface. Hot floating lava eliminated everything standing in its way. When magma reached the surface, its temperature was 1,000 to 1,200 degrees Celsius. It is 4 to 5 times hotter than a baking oven. What would happen to the cynodont caught in the middle of the magma river? Right, they were burnt to ashes in seconds. Eruptions set the planet on fire that spread so fast no creature could escape. Magma eruptions and earthquakes caused tsunamis. Tall waves would have hit and drawn dimetrodons and many other animals that lived in the oasis. Imagine that the thedoconts and echosaurs were lucky and magma and fires did not touch the oasis. Imagine there were only quakes and some dust storms. Even in that case, the clock was ticking and they were doomed. Magma released a huge amount of methane and carbon dioxide into the atmosphere. The planet's temperature went up by at least 2 to 3 degrees Celsius, and melted frozen methane in the ocean released it into the atmosphere. A greenhouse gas, methane, raised temperatures by another 5 degrees Celsius. All water on the planet evaporated and land dried up. The same happened in the oasis where the dinosaur ancestors lived. The greenery dried up and most animals died. Again, surviving reptiles had to look for another place. They kept moving, but there was only a barren desert. Poisonous acid rains fell from heavy clouds. It was difficult to breathe because of particles of lava, gases, and ash in the atmosphere. There was no chance of surviving in such a hell. It is a short description of the biggest extinction in the history of the Earth. It is called the Permian-Triassic extinction, or colloquially as the Great Dying. It wiped out 90 to 95% of water species and at least 70% of land species. Fortunately, some creatures survived, including cynodonts, because they hid in the burrows. The dinosaur ancestors, thecodonts and echosaurs, survived too. Soon, they would enter a new Mesozoic era and bring the famous dinosaurs to domination, while cynodonts, the predecessors of mammals, would have to adjust and wait for their turn. The planet took about 30 million years to recover from the Great Dying. Animals had to change and adjust to new conditions, and it took a long time. As you know, evolutionary changes take millions of years,